All right, today we're going to tackle something huge, network automation. We're talking about going from the slow, manual, click-by-click way of configuring things to running your entire network with code. So let's just dive right in.
So let me just ask you this. What if you could set up 100 switches just as easily as you could set up one? Think about that. The time, the headache, the sheer boredom of doing it by hand. Now picture getting all that done in the time it takes to do just one. That's not some far-off dream, you know. That's exactly what network automation brings to the table.
And look, the secret isn't about becoming the world's fastest typist on the command line. Not at all. It's about a total shift in how we think about this stuff. We're moving away from bossing around every single device one by one, and instead, we're teaching the whole network to listen and act on our commands all at once.
But you know, to really get why this is such a game changer, we kind of have to look back at the old way of doing things and see why it's, well, pretty much broken for today's world. It had its day, for sure, but its limits are really starting to show.
Oh man, yeah, this probably gives some of you flashbacks, right? If you're a network engineer, you know this pain. The same command typed out again and again and again on every single device. Every single time you hit enter, you're rolling the dice. Is there a typo? Did I forget a step? It's just so slow, it's begging for mistakes to happen. And honestly, it's a huge waste of time and talent.
But here's the good news. There is a much better way. We are right in the middle of a full-blown automation revolution. It's taking network management from this, manual, tedious chore and turning it into this sleek, efficient, software-powered process.
So what are we actually talking about when we say network automation? What is it? Well, at its core, it's the idea of using software to do the heavy lifting. We write code to automatically configure, manage, and even test our network devices. It's about turning all those boring, repetitive tasks into smooth, automated workflows.
Okay, but why? Why go through all this trouble? Well, the payoff is huge. First, you get this massive boost in efficiency, and you pretty much eliminate human error. I'm talking about no more of those late-night typos that bring everything down. That, of course, saves a ton of money. It's kind of like the assembly line for networks. You let the machines do what they're amazing at, doing the same task over and over, perfectly, without ever getting tired.
All right, so hopefully you're on board with the why. But the big question is how? How do we actually do this stuff? So let's open up the toolkit. We're going to look at the basic building blocks. And we'll start with the language we use and the data we're going to send.
And our main tool, our language of choice, is going to be Python. And there's a good reason why it's so popular for network automation. For starters, it's open source, but the best part? The syntax is super clean and easy to read. It almost looks like plain English. Plus, it's an interpreted language, which is a fancy way of saying you can just write some code and run it right away. No complicated steps in between. It's just perfect for jumping in and getting things done.
Okay, so we've got our Python script ready to give some orders. But what format do those orders take? You can't just shout at the network, right? That's where something called JSON comes into play. Just think of it as a super simple text-based way to pack up our data. You know, things like an IP address or a switch name into a neat little package that both our script and the network device can understand perfectly.
Now, you might have heard of something called XML. That was kind of the old way of doing things, and it can be pretty complicated and bulky. JSON is just simpler. It's much more lightweight, way easier for modern programs to read and deal with, and that's exactly why it's pretty much the go-to standard for this stuff now.
So let's see how this actually looks. It's really simple. It all starts with a pair of curly braces. That's our container, our object. Then, inside, we add what's called a key-value pair. The key is just a label, like first name, and it's matched with a value like Ollie. See? Super readable. And if you need more info, you just add more pairs, separated by a comma. So here we add last name and con. For us in the networking world, this might be hostname paired with switch-1, or IP address paired with an actual IP. It's that simple structure that makes it so incredibly useful for automation.
Okay, so JSON is great, but it's not the whole story. If we don't have any rules, we could just send any random JSON data we want, and that's a recipe for disaster. We need a blueprint, a standard way of saying, hey, for this task, this is exactly the information you need to send. And that's where data models come into the picture.
Let's make this real for a second. Think about configuring a network interface. You can't just throw random data at it, right? You know you need some very specific things. You need an interface name, You need an IP address, and you need a subnet mask. Right there, that list of things you need, that's basically a data model. It's the set of rules for that specific task.
So when we talk about a formal data model, all we mean is a standardized computer-friendly version of that list. It's a strict blueprint. It tells our automation script exactly what information it can send, what format it needs to be in, and what's mandatory. It just takes all the guesswork out of the equation.
So how do we actually write these blueprints? Well, the standard language for this is called Yang. It's probably the best way to think about how all these pieces fit together. Python is for writing the script, the logic, JSON is for packaging up the data, and Yang is for writing the official rulebook that the data has to follow. Okay, quick recap. We've got our script in Python, we've got our data format, JSON, and we've got our blueprint, our rulebook, written in Yang. So, what's missing? The final piece of the puzzle is the messenger. How do we actually get our request from our script to the network device? And the answer is an API. Now, API sounds technical, but the best way to think about it is like a waiter at a restaurant. It's a great analogy. You're the customer, and you have an order. You don't just walk into the kitchen and start cooking, right? No, you give your order to the waiter, that's your API request. The waiter takes it to the kitchen, that's our network device. The kitchen makes the food, and then the waiter brings it back out to you. That's the API response. The API is just that middleman, that messenger. In the networking world, we basically have two main waiters, or protocols that we use. There's NETCONF, which is kind of the old-school, super robust standard that uses SSH. And then there's the newer kid on the block, RESTCONF. It's more lightweight, it uses HTTPS, which is what the whole web runs on, and it plays really, really nicely with that JSON data format we were just talking about.
And these modern APIs, like RESTCONF, they use a super simple menu of actions. Instead of having to learn a bunch of complex commands, you just use a few basic verbs. You use get to ask for information, you use post to create something new. Put is for updating something that's already there, and delete, well, that one's pretty obvious. It's a really clean and powerful system.
Okay, let's put this all together. Let's see the whole thing in action, from start to finish. Step 1, our Python script creates the request. Step 2, it uses an API call, let's say RESTCONF, to send that request over the network. Step 3, the request itself is that package of JSON data we made, and it's following all the rules from our Yang data model. And finally, Step 4, the network device gets the message, understands it, and applies the configuration. Boom, all the pieces working together perfectly.
So there you have it. We've talked about the language, Python, the data, JSON, the blueprints, Yang, and the messengers, the APIs. These are the core building blocks of modern network automation. And once you understand them, you have the power to manage not just one device, but hundreds or even thousands, all with the same script. It's a complete game changer. So the only question I have for you is, now that you know how it works, what are you going to automate first?